So chapter 7 carries on where chapter 6 left off, where we had just talked about slope of a line and ways of calculating that, and also about the constant of direct variation, which was also the slope of a line. So we're going to carry on with linear equations and learn a new form of linear equation. So when we were introduced to linear equations in chapter 6, we said there was a standard form. And the standard form of a linear equation was a coefficient in front of an x term, a coefficient in front of a y term equaling some number. And that might have been a 0. We saw, the oddball horizontal and vertical lines, but this was a linear equation in the standard form. We were taking those standard form linear equations and solving them for y in a fairly specific way. And the reason why we were solving for y in a fairly specific way was this 7.1, the slope-intercept form of a linear equation. So what it does is it takes the standard form linear equation and solves it for y. And the reason why this is so awesome is that it allows you to see the slope and the y-intercept of a line direct from the equation. No subbing in, no calculating the intercepts, no like XY charts, none of that. So this is still a linear equation. It's a different form, right? It's not the standard form. It's the slope-intercept form. And when we take a look at this, the m is always the slope and the b is always the y-intercept. So we remember that the y-intercept when we were solving for intercepts was that x equaled 0. That's how we found the y-intercept. And y-intercepts are always 0, comma, something, right? So this b value is the y of the y-intercept. If the b happens to be negative, that just means that it's a negative y-intercept. So that introduces you to the slope-intercept form. We're going to go back to our old ways here and really just test this slope-intercept form in the transition between chapter 6 and chapter 7. I also find that in chapter 6, you learned how to put an equation on the graph two different ways. You learned it with the table method and you learned it with the intercept method. I find that once we get into chapter 7, the slope-intercept form is so much more powerful. It seems to eclipse the table method or the intercept method that we were using through chapter 6. So recognizing that they all do the same thing is really key here. And we'll talk about all of them because they do all have their merits. We're going to go back to our old ways, like it says, to test this form. And so we're going to use a table of values to graph this linear equation. So this linear equation is already solved for y. It's also already in the slope-intercept form, but we don't even have to pretend that we know that at this point. So this is where you get to choose the values of x, and then you're going to solve for the values of y. That's the way we did the table method for getting these linear equations onto the graph. So there's nothing specific about the values of x that I could choose or need to choose. I'm going to pick 0, 1, and 2 because I almost always do. In picking this 0, 1, and 2, that allows me then to sub in a 0 where I see the x, and then solve for y. And then I'll sub in a 1 where I see, whoops, sorry, copied that wrong, where I see the x and solve for y. And the third point, just as backup here, 2 would actually do it. A 2 where I see an x and solve for y. So I get these three ordered pairs that I can read out of my table and put on the graph. So x being 0, y being 3, x being 1, y being 5, and x being 2, and it's off, but at least backs up my concept here. So I'm going to try and do this carefully. We'd have a straight line. Oh, shoot. It looks something like that. So hard for me to draw a straight line on this tablet. Look something like that. And so what we're going to do with this is check this out. So if we were to take a look at what's going on here, this one says, what is the slope of this? Well, we can take a look. We could count it off the graph. So it goes up 2 and over 1. It has a rise of 2 and a run of 1. If I were to take a look at what is in the m value here, it's a 2. So slope would equal, or my m value would equal, a rise of 2 over a run of 1. The other thing here is, what is the y-intercept? And we can just read that off of the graph. So the y-intercept, if I take a look at it, is right here. So the y-intercept is 0 and 3. I can see that my b value is 3 in my equation. And so, they're doing the same thing. This is one way of getting the equation on the line, and this is another way of getting the equation on the line. When you're using the slope-intercept form, you need to start with the y-intercept, because this gives you a point to start at. This gives you instructions to go to the next point. So that's really, in a nutshell, stuff that we've learned in the past and where we're going with this slope-intercept form. So it's y equaling mx plus b, where m is the slope and b is the y-intercept. That's really what this is all about. So we're going to practice some of these on the next page. Key thing about linear equations is sometimes they are given to us in standard form. So sometimes the linear equation is not in this slope-intercept form. We have to rearrange it to get it there. So we're going to use the rules of algebra to solve for y and put it in slope-intercept form. So we want y equaling mx plus b. Really, it's in descending order, and it's solved for y. So for a, if I am solving for y and, in a sense, putting this in my slope-intercept form, I would subtract 3x from both sides and get 2y equaling negative 3x plus 6. Remember that I'm putting this in descending order, right? X term first, so descending order, much like how I had said back in chapter 6, like I know where we're going with this, so we're going to do it in a specific way. The last part here is to divide by 2. And so my final answer here would be y equals, I'm going to see this negative 3 over 2 as the fraction that it is, because that's useful for me to see my slope as a rise over a run, x plus 3, because you remember you have this 2 dividing into that term and into that term. You can't pick and choose. It has to go into both of the terms in that binomial on top. So this would be that same linear equation. It's the same line on the graph, but it's in a different form. It's in the slope-intercept form, where you can see the m value and you can see the b value. This is the slope. This is the y-intercept. So let's try the rest of these. Again, we're just practicing solving for y in a sense. So c would have minus 4x on both sides. When I do that, I'd have 3y equaling negative 4x plus 12. I'd have to divide by 3 on both sides. And I do this funky thing that we've seen several times now, where I break apart the binomial and I break apart the number. So I have a coefficient on my x. So negative 4 over 3x plus 4. Again, don't forget to divide that last term by the number down below. The ones down here on the bottom, I'd start by subtracting 2x on both sides. And that would give me negative 5y equaling negative 2x plus 10. And solving for y, I'm dividing by negative 5 on both sides. So as always with negative signs, watch those signs. My final answer here would be y equaling a positive 2/5, because it's a negative 2 divided by a negative 5. So 2/5 x minus 2, because I have 10 divided by negative 5. Always with the negatives. And last one, here in using the skill of solving for y or putting them into the equations into slope-intercept form. Start by subtracting 2x on both sides. Negative 3y equaling negative 2x plus 6. Divide by negative 3 on both sides. And my final answer here in slope-intercept form, or solved for y, is 2/3 x minus 2. So now that we have, that skill practice of going from standard form to slope-intercept form, we're going to go back and help or practice interpreting things, interpreting equations that are in slope-intercept form. So I had said on the first page, we always start with the y-intercept. We're going to do the y-intercept first, and then we're going to do the slope. Because when you're graphing this, you need a point to start at, right? That's what the y-intercept is, and the slope is really just directions. They're instructions on how to get to the next point. So when I take a look at A here, I could see it is solved for y. It's in slope-intercept form, where I have negative 2/3 is the m, and negative 5 is the b. We know that my y-intercept then, we always start with that, is 0 and negative 5. I like putting it as a point to reinforce that this is somewhere you can put on your graph to start. The slope for this is the m value, so the slope is a negative 2/3. I find it's more convenient to put the negative with the thing on the top because that tells you whether you're going up or down. I get a little bit directionally challenged if it's left and right stuff, and so I put this negative that's out the front here with the numerator here because that tells me from this point 0 and negative 5. I'm just going to do a real sketchy one here. So 0 and negative 5, and from there I'd go down 2 and over 3 to get to the next point in order to put this on the line. I'm getting ahead of myself, but I do think it's important to kind of have context of why the heck we're doing this. So B, moving on down here, I'd have a y-intercept if I'm just reading it out of the equation, because that's what's so awesome about slope-intercept form. A y-intercept of 0 and negative 7, and a slope, that coefficient on my x term is a negative 3, or more usefully, I could see that as negative 3/1. Hard to believe, but fractions are actually more useful than whole numbers in this case, because that tells you from this point of 0 and negative 7 to go down 3 and over 1. I'm going to keep going down here. So my y-intercept with this equation, that's all we're doing here. I'm getting ahead of myself. My y-intercept is 0 and 5, and my slope would be 3/4. Ones over on the other side are a little bit weird, and so I'm just going to erase what I put there because I can't really fit it all in. When I take a look at D, part of this is invisible in slope-intercept form. So what's missing is the y-intercept. You could put a +0 there so that you can see what the b value is. So my y-intercept for this, with the cloak of invisibility removed, would be 0, 0. Remember that x is always 0 and your y value is your b term. And here it's super invisible as a 0. The slope for this one is still just that coefficient of my x term, so that's 2/3. For E, again, with the invisible stuff, we know that there is a 1 in front of any variable that we can see. I'm going to start with the y-intercept for this one. My y-intercept is visible here, so it's 0 and 2, because my b value would be a 2. And my slope for this one is just 1/1. So that tells me from my y-intercept of 2, to get to the next point on the line, I'd go up 1 and over 1. And my line would look something like that. Okay, so these are all oddballs. If you remember them, they are super strange, and I think it's always worth sort of graphing them or conceptualizing them. So these would be the two graphs of those two lines. You may be able to look back in your notes and recognize that this F is a horizontal line. It does have a y-intercept. The y-intercept is 0 and 1. It has a slope of 0. It means it doesn't go up any and it goes over lots, if that makes any sense to you. Sorry, G, if we take a look at that one, a line at x equaling 2, there is no y-intercept for that vertical line. It never touches my y-axis. And its slope, as we talked about before, is undefined. So things get a little bit weird. These two oddballs being the horizontal and the vertical, it's the only downfall of this slope-intercept form. It's really hard to see how those two linear equations actually fit the slope-intercept form. And so I think it's best with these ones to just give them the extra attention and go back to what we know about them conceptually. So the next part of the notes takes and rolls it kind of backwards. So it gives you the intercept and the slope, and it says write the equation of the line. So we know that y equals mx plus b. We know that that m is the slope and the b is the y-intercept. And so we can go backwards from this. We know that if we put it in slope-intercept form, we'd have y equaling, our slope is negative 3 over 4. We'd put an x in there and a minus 3. I could see that this minus 3 is my b term. Remembering that when it's a negative intercept, it's a negative b. You just read it straight out. These ones, after you kind of catch the hang of them, aren't super difficult. For b, I would have y equals a negative 2x plus 7. Negative 2 was my slope, and 7 was my y-intercept. Two more. This one says that my slope is 2/3, so y equals 2/3 x, because that's the coefficient on my x term. That's the m value is my slope, and a minus 3, because I can see that my b value is a minus 3. The next one down here, I would write out y equals a negative 2/3, because that's what it says my slope is, x. And you can put in the plus 0 because it has a b value of 0, but typically we would just leave that out. You know, you wouldn't bother because it's understood to be there. If it helps you to put it in, go ahead and put it in, but I think this is, you know, it's worth having in the examples so that you can see, you know, when it's there and when it doesn't need to be there. So now that we have a little bit of more familiarity with the slope-intercept form, we're now going to use it to put an equation on the graph. And I've kind of already got ahead of myself in this and shown you some of that. So if you're given a linear equation, you can use the slope-intercept to put it onto the graph paper. So the first thing you're going to do is make sure that it's in slope-intercept form. In everything that we've talked about, it's solving for y. And it's solving for y in that funky way where you put it in descending order. And also do that funky fraction bit as your coefficient on the x. The next thing you're going to do is interpret it. So we interpret the y-intercept first and the slope. You're going to plot the y-intercept, and then you're going to use the instructions that are slope to determine other points on the line. You can do it once or you can do it more than once. So this is start here. Start always with your y-intercept, and then you use your slope. So use the slope as instructions to get to other points on the line. So just as a quick overview here, it's always worth kind of taking this as a bit of a review. We've done this one before. So a positive slope would be up and then over. When I say over, I mean right. When we had the negatives, I said it's easier to put it with the up down. So if I go from one point to another point on the line, I would be going down and then over. And again, by over, I'm defaulting to right. These 0 and undefined are the oddballs. So in these ones, the slope of this is 0 and the slope of this is undefined. I like going the distance on this. There is a y-intercept. There is no y-intercept here. The other thing is the general format of these, and it's that y equals something, right? In this case, it could be, if we put some lines on there, it could be that y equals 3. In this one, if I do, again, like what the equations look like, it would be that x equals something. And in this case, I put some marks on there. So as a concrete example, x equals 3. Again, these two over here don't fit the y-intercept form as well. And so I think it's worth kind of doing the whole meal deal of conceptually understanding them as you go through these. All right, so let's do this. Let's put these together. So if you are given an intercept and a slope, we can practice putting these on the graph. And so we're going to start here. You have to start with the point. So you would start at 0 and 2. And then my slope tells me the instructions. That goes up 2 over 3 from where you started. So where I started, I go up 2 and over 3. The slope is not an ordered pair. This is an ordered pair, so that's a location on the map. This slope is really just instructions, not an ordered pair. So that gives me enough as the equation line, especially because I'm such a bad drawer of straight lines on this. I would go, oops, I counted that wrong. I didn't actually go over 3. Sorry about that. All this explaining, and it's really just my counting that's at fault here. Okay, so I'd go up 2 and over 3. You can do it more than once. If you wanted to, you could go backwards with this. We know that a negative over a negative is a positive, so we could actually go down 2 and to the left 3. And you can see that that lines up in this straight line. So again, what I did was like make it a negative 2 over a negative 3. That tells me to go down 2 and over 3. And again, the only reason I'm doing this is because I am so terrible, oh, almost hit them all, at drawing a straight line. So that line on my graph is A. If I put B on my graph here, I have an intercept of -2, so 0 and -2, you always start with the point. And then this instruction tells me to go down 3 and over 5 to get to the next. So from my point, I go down 3 and over 5. And you could put more on the graph. I'm going to stop short with that because I think I can almost hit them. Yay! So that would be your equation for B. And if you wanted to, you could reverse it and go up the other way there. So that gave you a point and a slope to put. How about if it was just on it or in an equation? So on the back side of your homework, there is a fun thing to do. I'm not sure. Whom should you see at the bank if you're looking for a loan? And there's a dorky answer to that riddle. It's supposed to be fun to do. I do like doing this stuff, and really the way you do that worksheet is a lot like these. So we're going to put this equation on the graph. And so I write out my interpretation. My y-intercept is going to be 0 and 3. Again, that gives me a point to start at. And my slope, I write it out so I can see what the instructions are. That would be a 2 over 1. So I start with the y-intercept, that's 0 and 3, and then my slope tells me to go up 2 and over 1. So from my point, I go up 2 and over 1. And you could keep doing that, you know. Again, I'm going to, because my line drawing is so terrible, to put the equation or the line on the graph. The next ones, if we do these, we're going to do them the same way. We're going to start with the y-intercept. When I read it out of my equation, it's 0 and -4. That gives me a point to start at. And my slope is going to give me the instructions to get to the next point on the graph. And so I'm going to put the negative with the 1 and the 2 underneath. So this tells me to start at 0 and -4. That's my y-intercept. And from that point, I'm going to go down 1 and over 2. And remember, when I said over, I'm defaulting to right. So down 1 and over 2. I could do it again, down 1 and over 2, just to get another kind of backup on there. I'll pretend I'm better at drawing lines. And I'm going to say that's close enough. That's what B looks like. So this was A. That's B down there. And what about C? When I take a look at this, this is one that's missing its B. It's missing its B. So its y-intercept is actually 0, 0. That's the origin, right? And from there, we look at the slope. So the slope tells me it's -1 over 3. So these are my instructions. So from 0, 0, I'm going to go down 1 and over 3. And I could do another point. So another point is going to have the same instructions to get to. So down 1 and over 3. And again, I've got enough points on here. I can draw my line on the graph. Of course, you're using a ruler and your graphs are looking far neater than mine are. So bottom line with this, start with the y-intercept and then use the slope as the instructions to get to other points on the line. If it helps for you to write out, the instructions and what they mean, then go for it. You will probably get better at reading those instructions out of the slope. So at this point, it's a good time to kind of summarize that we've learned how to put graph or lines on graph paper 3 different ways. And so all 3 methods will result in a line on a graph, and sometimes one way works easier than others. All of them should give you the same line. And so just as a quick recap, we had the table method. And that was really useful when you had no coefficients. So we would solve for y. So y would equal a -x plus 6 in this case. And then you get to choose those values of x and solve those values for y. In this case, I don't have any limitations on my choices. So I'm going to pick 0, 1, and 2. We were doing 3, but you don't have to. If I were to kind of show my work here, I've kind of given myself not a lot of room. So maybe I'll just switch it up this way. So subbing in the 0, I'd have y equaling 0 plus 6. And again, so that would be a 6. For the 1, I would take y equaling -1 plus 6, and y would then equal 5. And the last one, again, all I'm doing is subbing in the 2 where I see the x, so y equals a -2 because it was a -x. Plus 6, or y equals 4. So putting those 3 points on the line or on the graph, I'd have 0 and 6, 1 and 5, and 2 and 4. And you could totally just put this in, when you solved it for y, you put it in y-intercept or slope-intercept form. But in this case, this is just a recap of the table method. The intercept method is particularly handy when you've got coefficients all over the place. And so we've got coefficients all over here. If you do solve for y, you're going to be stuck putting in those fractions. I still don't think it's that big a deal to put it into the slope-intercept form, but that could potentially be a reason why you would use the intercept method. So just as a recap, the y-intercept, you say that x equals 0. And in this case, it would be that 2 times 0 plus 3y equals 12, or y equals 4. So that gives me a point of 0 and 4. If I did the x-intercept, because you needed another point on the graph, that's when y equals 0. And so subbing in a 0 when I see the y gives me something that looks like that. And again, I like subbing in zeros because it makes it quick. So I get that x equals 6 in this case. So I get another point of 6 and 0. And so I've got 2 points. That's all you really need to put something on the line. And so in this one, if I put these on the line or on the graph, I'd have 0 and 4. as my y-intercept and 6 and 0 as my x-intercept. And I try really hard to hit both these dots. Ooh, not too bad. 4, E. So that was D, that's E. Let's do the last one. And the slope-intercept method for this one is particularly useful because it's already solved for y. I can see that I have a y-intercept of 0 and -3. No crunching of numbers required. That's why I think I like this one. And a slope, because I have an m value of -1 over 2. So putting that on the graph, it's really just about reading the information out of the equation. So I start at 0 and -3, and then I use my slope as instructions to get to another point on the line. So I go down 1 and over 2. Again, this is telling me down 1 over 2. And I can do that between any 2 points on the line. So down 1 and over 2. So that's how you would put that equation on the graph. And again, you can do that or any of those 3 methods for putting equations on a line. I tend to be partial to this one, mostly because it's not about subbing in and solving. It's really just about understanding this format of the linear equation.